Hello, I hope all of you can hear my voice.
Yes, ma'am, audible.
So we will solve the problems regarding this reciprocal lattice and all. That's what I taught you in the last week. Okay. So the first problem, which is a direct cubic lattice, has the following primitive translation vector having length in angstrom. A is equal to a plus a j plus k, b is equal to a I plus k, and c is equal to a I plus j. Find out the volume of the primitive cell for the its reciprocal lattice. Okay, so see here first. What we have to first we have to see the primitive translation vector. It is ABC, which is given in the question. So volume of the primitive cell for its reciprocal lattice, we have to find it. Okay, so the reciprocal lattice vectors, it's already we know that from the classes. It's a dash is equal to 2 pi b cross c divided by a dot b cross c. Similarly, b dash will be a 2 pi c cross a divided by a dot b cross c, and c dash will be 2 pi a cross b by a dot b cross c. Okay, so let's calculate a dot b cross c first. That's for volume in the real space. So you have to do the vectoral dot product and all here, cross product, and do it, and you will get the volume. It will be 2a cube. Okay, after doing that, see, then from there you have to calculate the a dash, b dash, and for this problem. Okay, so everyone please try to do yourself first. hope all of you are doing the problem. I hope all of you finish this question. We will go to the second one. A direct cubic lattice has following primitive translation vector: A is equal to 3i plus j, B is equal to 3j plus k, and C is equal to 3k plus I. The reciprocal lattice corresponding to the above lattice is. So we have to. So here the given A vector is equal to 3i plus j, B vector is equal to 3j plus k, C vector is equal to 3k plus I. Okay. Now we have to find the volume first. Volume V is equal to A dot B cross C. Okay, so 3 into I plus j plus k times 3 into k plus I. Okay, so it will be like 27 I plus j into I plus j minus k. Okay, so it will be 27 into 1 plus 1. 27 into it will be 54. That will be the volume. Okay, now same way like whatever we have done the early first problem, same way you have to solve for the ABC. So like A dash is equal to 2 pi B cross C divided by volume. So it will be 2 pi divided by 54 into B cross C. Okay, so it will be like pi by 27 into 9 times I plus j minus k is equal to pi by 3 I plus j minus k. Similarly, you have to calculate B as well as C dash. Okay, pi by 3 minus I plus j plus k. Okay, and C you will get it pi by 3 I minus j plus k. Okay, so if the reciprocal lattice will be like BCC. Please try to do this and get your answer. Then we will do the next one. Now we will go to the third problem. A direct cubic lattice has following primitive translation vector having A is equal to 2i, B is equal to 2j, C is equal to 3k. Okay, so find out the cube edge of the reciprocal lattice corresponding to the above direct lattice. So here what you have to do, we have to find the reciprocal lattice, same kind of questions only this time on this one also. A dash, B dash and C dash we have to find. So V is equal to V cross C. Okay, so 2i into 2j cross 2k. Okay, so it will be like 8i into j cross k. So volume will be 8. Okay, volume in the direction of direct lattice. Now you have to find same way A dash and similarly B dash and C dash. Please calculate and please let me know your let me know answer by chat box. Okay, please solve it and try to write your answer in the chat box. I will check it. please give your answer in the chat box, just like normal values a dash, b dash, and c dash. So here you will get the answer a dash is equal to pi I, b dash is equal to pi j, c dash is equal to pi k. So that is the answer you will get from this question. Now we will go to the next question for fourth one. The primitive translation vectors of hexagonal space lattice may be taken as A is equal to AI plus A by 2j and B is equal to minus AI plus A by 2j and C is equal to AK. So determine one of the primitive translation vectors C dash from the reciprocal lattice. Okay, so here you have to find only C dash, C star or C dash, whatever. Okay, so what you have to do here, so whatever the parameter given A, B, C is given. So we have to find the volume. First volume will be A dot B cross C. So here you have to do A into I plus j by 2 dot B cross C. Okay, so B cross C, first once if you do, you will get that I plus j into 1 over 2 I cap plus j cap. Okay, so here answer will be like A cube into 1 over 2 plus 1 over 2. So it will be A cube. So that will be your volume. Now you have to find the C star here. So it will be 2 pi A cross B by volume. Okay, so substitute all the values, you will get 2 pi by A k cap. So just substitute A cross B, find A cross B and substitute here, you will get C dash value. I hope you are doing this and getting the answer. Then after that we'll go for the fifth question. So we will go to the next problem. A two-dimensional direct lattice be formed from a repetition of primitive cell ABCD shown in the figure below. Length of the primitive translation vector of the direct lattice A is equal to A, that is AB is equal to DC 2 angstrom and BAD is equal to BC 3 angstrom. The angle DAB is 45 degree. Calculate the length of the primitive lattice parameters. Okay. So here, so in the question it is given that A is equal to AB is equal to DC, that is 2 angstrom. Okay, and B is equal to AD is equal to BC, that is 3 angstrom. So angle DAB, which is given 45 degree. Okay, now we have to find A, the area that is equal to A cross B, that is equal to AB sine theta. So it will be 6 by root 2 A square, that is 6 sine 45. So it is 6 by root 2 A square, angstrom square, we will get it. Okay, now lattice parameter we have to find. So it will be like A dash is equal to 2 pi B vector divided by the area. Okay, so it will be like 2 pi into 3 divided by 6 by root 2. So it will be 6 pi root 2 divided by 6. So it will be root 2 pi angstrom inverse. Okay, now we will get A dash is equal to 2 pi v, that is A dash. Similarly, you have to find the B dash, that will be is equal to 2 pi A dash divided by area. So it will be 2 pi into 2 divided by 6 by root 2 angstrom. So it will be 2 pi root 2 by 3 angstrom inverse. So this will be the answer. So here we have to think of like it is a 2D plane. So it will be as a area. Earlier we are doing with the volume. Okay. It's a surface now. Now we'll go to another problem. Consider BCC structure consists of identical atom in a unit cell. So position of the atoms in the maximum atoms in the unit cells are 0, 0, 0, 1 by 2, 1 by 2, 1 by 2. The intensity of the diffraction beam become maximum when HKL is even or HKL H plus K plus L is odd or H plus K plus L is odd and even integer both or none of the above. So it is a BCC structure it's given, right? So A value 0, 0, 0 and B value half, half, half. So the intensity of diffracted beam is the maximum when it will be. So the total scattering amplitude we can take it as F H dash K dash L dash. So we know that the structure scattering value, that structure factor value. So it will be F summation over J to e raised to 2 pi I into U J H dash plus nu J K dash plus Wj L dash. So it will be I1 plus e to the power I pi h dash plus k dash plus L dash. Okay. So the structure factor becomes 0 when e to the power I pi n is equal to -1 where n is equal to odd. Then h dash plus k dash plus L dash, that will be odd values. And for even number it will be h dash plus k dash plus L dash, that will be e to the power I pi n is equal to +1. So here f will be 12. So intensity will be 4f square. So this is the answer for this question. Okay.
And that means option A is correct, ma'am.
Now, next question. The nickel crystallizes in a cubic system. So,
Ma'am,
following
please 1 minute,
thin
ma'am.
powder diffractogram it observed that the reflections from 100 and 110 are absent. The first reflection in the power pattern of the nickel is observed from 111 plane. What is the Brady's lattice? Okay. So it will be like nickel cubic crystal structures. Absent reflections are 100, 110 planes. Okay. And the present reflection will be 111. So H plus K plus L is equal to 1. So for FCC, H plus K plus ratios are like 3, 4, 8, 11. So our answer that will be FCC structure. It's like basic theory. We have to attend the class and get it.
Ma'am, previous question. Ma'am, ma'am, good evening, ma'am.
So this is an easy question. You have to know the basics. Now we'll do the next one. And the unit cell dimension or lattice constitution of
Madam,
NaCl lattice is 4.92 angstrom. If an X-ray beam of wavelength lambda is equal to 1.1 angstrom falls in the family of plane with separation of A by root 5 angstrom. So maximum how many order of the diffractions are observable? Okay, so the lattice constant of NaCl which is given 4.92 angstrom. So lambda given 1.1 angstrom. So separation between the plane D value is also given. Just you have to use the Bragg's law. So it will be 2D sine theta is equal to n lambda. So sine theta maximum will be 1 that we know already. So 2D is equal to n lambda will come. So n you have to do 2D divided by lambda. So 2 into A by root 5 into 1.1. So it will be 2 into 4.92 divided by 1.1 into root 5. So n will be 4. That will be the answer. Okay. Now we'll go to the next one. The X-ray wavelength of 1.5 angstrom are deflected at an angle 10 degree from set of a parallel plane of a crystal, and the product produced the first order Bragg diffraction. Find the spacing between the adjacent planes. Okay. Also here the lambda will be 1.5 angstrom. It is given in the question, and deflected angle it will be 10 degree, that is 2 theta, that is 10 degree. Okay, and reflected angle theta, that will be 5 degree. Now n is equal to 1, the first order Bragg diffraction. So you have to just use the Bragg's formula. N lambda is equal to 2d sine theta. So you will get it, d is equal to n lambda divided by 2 sine theta. So it will be 1 into 1.5 divided by 2 into sine 5 degree. So it will be 8.6 angstrom. So your d value will be 8.6 angstrom. So whatever I am solving here, these are the questions which will be, it was there in the assignments, earlier year assignments and earlier year's problem sections. Okay, so definitely you have to study this, and it will be helpful for you to solve this year assignment and as well as the your exam. I hope you got this answer. Now next one, the spacing between principal plane in a sodium chloride crystal is 2.82 angstrom. It is found that the first order Bragg reflection is same on the monochromatic beam of X-rays occur at the angle 10 degree. At what angle would be the second order reflection occurs from the same planes? Okay. So here spacing between that will be D is equal to 2.82 angstrom. Okay, then first order diffraction, so n will be 1 and theta 1 will be 10 degree. Now n is, we have to find n equal to 2, what will be theta 2. Okay, so n lambda is equal to 2d sine theta. So n1 divided by n2 will be sine theta 1 divided by sine theta 2. So it from there 1 over 2 it will be sine 10 degree divided by sine theta 2. Okay, so from the sine theta 2 is equal to 2 sine 10 degree. So from there you have to find sine inverse of 2 sine 10 degree. Then you will get the angle theta 2 is equal to 20.31. So simple questions would you have to remember the formula and do it. That's it. We'll go to the 11th question. The wavelength of the X-ray to be determined using simple cubic crystal. The Bragg's angle of the first order reflection from 110 plane is 20 degree. What is the wavelength of X-ray? The lattice parameter of the crystal is 3.14. Okay, so the Bragg's law. So it's like n is equal to 1 and 20 degree in 110 plane. Okay, so lambda we have to find it. A is given 3.14 angstrom. Now we know that d is equal to a divided by root of h square plus l square plus k square. Okay, now you have to use n lambda is equal to 2d sine theta formula. If n lambda is equal to 2a sine theta divided by h square plus l square plus k square, substitute all the values, then like 2 into 3.14 into sine 220 degree divided by 1 into root of 1 square plus 1 square plus 0 square. So you will get lambda approximately 1.518 angstrom. So do it from your side, then we will go to the next one. We'll go to the another one. The bright angle corresponding to the first order reflection from 111 plane and simple cubic crystal is 30 degree. Okay. When the X-rays of wavelength 1.75 angstroms are used, calculate the interatomic spacing between the crystals. Okay, spacing of the crystal. Now here actually interatomic spacing we have to find it. So it is like symbol cubic. So the distance between two atoms 2r will be a. Okay. Now Bragg's law, we know that n lambda is equal to 2d sine theta. From there we have to do d is equal to n lambda by 2 sine theta. Okay, substitute the value 1 into 1.75 divided by 2 into sine 30 degree. So it will be 1.75 angstrom. Okay, from there you have to calculate A is equal to D into root of h square plus k square plus L square. Okay, so then 1.75 into root of 1 square plus 1 square plus 1 square, so root 3 you will get it, and you will get the final answer 3.03 angstrom. Okay. we will go to the next problem. Next problem is different one. So that the error in determining lattice parameter decreases with increase in diffraction angle. Okay. So lattice parameter measurement is very indirect process. So for a cubic system, we know that A is equal to D into root of h square plus k square plus L square. And D is the spacing in measure from the Bragg's laws, and lambda is equal to 2D sine theta. The precision parameter of A or D depending precision angle of the deviation sine theta. Okay, so see the degree and sine theta. So if theta increases, sine theta values increase, in the maximum value will be 1, and delta sine theta will be the very small value. Okay, in if you see the sine theta value, and if it the delta theta value is high, but the corresponding delta sine theta value will be small, so that value which changes will be very small. Okay, so the diffraction of the Bragg's equation with respect to the theta provide us the same result, lambda is equal to 2d sine theta. So take a partial derivative for the Bragg's equation. To calculate the error, we have to take the partial differentiation. So then it will be theta is equal to 2 delta t sine theta plus 2d cos delta theta. So delta d by d is equal to minus cos theta by sine theta delta theta. So that is equal to minus cos theta delta theta. So for a cubic system, A is equal to d dot root of h square plus k square plus L square. So therefore delta A is equal to delta d root of h square plus k square plus L square. So from there we can say delta A by A, that will be is equal to delta d by d, that is equal to minus cot theta sine theta cot theta delta theta. So the term delta A by A or delta d by d is the fractional error in the A or D caused by the given error in theta. So fractional error only in A. Okay. So the fractional error approaches 0 as theta approaches the 90 degree. Okay. So that is the error calculation. Next problem actually related to this. So please go through it. Then we will solve the problem for the next question. We'll go to another problem. For the first order diffraction peak of a crystalline solid so called the scattered angle 30° when the diffraction pattern is recorded using the X-ray beam of wavelength 0.1915 nanometer. If the error in measurements of the wavelength and the angle are 0.01 nanometer and 1 degree respectively, then the error calculation the interplanar spacing will be approximately. Okay, so here if you see, we have to like so the d value which will be how it will be lambda by 2 sine theta. Okay, so dou lambda is equal to 1 by 2 sine theta and dou theta is equal to minus lambda cos theta divided by 2 sine square theta. Okay, now the sigma d square, the error in the d can be calculated as sigma d square. So dou d by dou lambda square into sigma lambda square plus dou d by dou theta into theta square into sigma theta square. Okay, so dou sigma d square divided by d square will be 1 over 2 sine theta whole square plus 2 sine theta divided by lambda whole square into sigma lambda square. Okay, and plus minus lambda cos theta by 2 sine square theta whole square into 2 sine theta by lambda whole square into sigma theta square. Okay, so sigma d square by d square is equal to sigma lambda square by lambda square plus sigma theta square by tan square theta. So then from here you can get the sigma d is equal to d by root 2 of all these values. Now substitute all the values, you will get sigma d will be 1.1 into 10 to the power minus 2 nanometer. So substitute all the values, so theta value everything is given. Okay. Now we will the another question. In a powder diffraction experiment using copper K alpha radiation of area to 1.54 angstrom, and the first 5 lines are observed from the monochromatic cubic crystal when the angle 2 theta is 38 and 44.2 and 64.4 and 77.2 and 81.4 degrees. Okay. So determine the crystal structure and the lattice parameter. So here what we have to do is sine theta will be n lambda by 2d. So sine theta which will be lambda root of h square plus k square plus l square divided by 2a. Um, like sine theta is equal to lambda by 2a root of h square plus k square plus l square. So it will be sine square theta is equal to lambda square by 4a square into h square plus l k square plus l square. Okay. So sine square theta which is proportional to h square plus k square plus l square. Now we have to make a table like line 2 theta, theta, sine square theta and ratio. So here 1, 2, 3, like 5 angles which is given. So it will be like 38, theta will be 19, sine square theta will 0.1060, here it will be 30. And second one the angle will be 44.2 and theta will be 22.1 and 0.1415 and 4. Okay, and this one will be 64.4, 32.2, 0.2840 and 8 degree. Okay, like that. Still fifth one you have to do. So the ratio will be like 3, 4, 8, 11 and 12. So which is I have already discussed, it will be like FCC lattice. Okay, so our system which is given, it is FCC lattice. Now a value you can find it is A is equal to lambda square by 4 sine square theta into h square plus k square plus l square. So it will be sine square theta is equal to 0.1060. So h square plus k square plus l square will be 3. So a value will be 4.10 angstrom. So this is the way you have to solve this problem. Okay. Now we'll go to the last problem, which is also important problem. It's a little bit bigger. So the powder pattern of a cubic crystal gives the first three S values of 56.8, 94.4, and 112 millimeter. Okay, the radius of the camera is 57.3 millimeter, and the wavelength of the monochrome radiation is used is 1.54 angstrom. Determine the crystal structure and the lattice parameter of the material. Okay, so first three S values are 56.8 and 94.4 and 112. The radius of the camera is 57.3. So the angle theta corresponding to the particular pair of the R's is related to the distance S. So between 4 theta is equal to S by R. R is the radius of the camera and theta is in the degree. So 4 theta is equal to 57.296 by R. So the radius R is equal to 57.3 millimeter and 4 theta is equal to S. We can say that for S1 is equal to corresponding 4 theta 1. So theta 1 will be S1 by 4. It will be 14.2 degree. Similarly, theta 2, theta 3 you have to calculate. And we know that sine square theta is proportional to h square plus k square plus L square. So sine square theta 1 plus sine square theta 2 plus sine square theta 3. Substitute the values, you will get the ratio 3 is to 8 is to 1. 8 is to 11. So for diamond cubic, the ratio should be called 3 is to 8 is to 11. So the lattice parameter of the material A will be L lambda is equal to 2d sine theta. D will be, and A will be d into h square plus k square plus L square. So A is equal to L lambda divided by 2 sine theta into root of h square plus k square plus L square. Substitute all the values, you will get the A value. So it's a simple problem, but you have to know the formulas. Okay, that's it. So just go through that, then we will just go through some theory part where how you can calculate the hexagonal crystal structure Miller indices. So see here for direction in HCP crystal. So to emphasize that crystal is equal like A1, B1, okay. So the value here you can see A1, A2, A3 and C. So there will be four coordinate system which is used for this then A1, A2 and that A3 we can write it as minus A1 plus A2 and C. So that is the four coordinates. So for you want to find the Miller indices. For example, for the Miller indices, we have to do the find the intercept R and S. So it will be like HKIL. Okay, so for indices will be HKIL and I will be minus of H plus K. So that will be corresponding to the third axis. Okay. Now what is the Miller indices of the pink plane here? If you see the pink plane here, so here it is actually touching the A1. So here H will be 1. Okay, and A2 it's not crossing, so it will be like parallel to that. It will be like opposite direction, so we can tell it as negative. So 2 bar. Okay, and A3 axis is cross touching, that's it will be 1, and C axis is parallel, so it will be 0. So this is the way you have to find it. Okay, now see the plane, the above plane, whatever here is showing. So H and K and I will be 0. It's only in the Z axis, so it will be 0, 0, 0, 1. It will be in the C axis. Now see here, this plane, so it will be like A1 it is touching and what is happening, a3 will be the negative side, and in means a2 will be the negative part, and I will be what, minus of h plus k. So it will be 0 and I will be 0 because it is parallel to the c axis. So okay, now so this is the important thing. So this PPT I will include in the drive, so you can access it. Then I have included that weakness cells, how to calculate also, and some more problems. These are very basic problems, which is the earlier year assignments. You can see from the other TA's classes also this assignment solutions. And this is just weakness cell, how you have to calculate the weakness cells parameters. Okay, so for that, so you can just go through it when you are getting the PPT. I will upload it today. Okay, hopefully I think you understood the class. And actually the recorded class and everything is already sharing. I think NPTEL platform you will get it, the YouTube link also. Videos are uploading in YouTube, so you will get the YouTube link as well as the PPT itself. Okay.
Hello, ma'am.
See you
Where I
in the
can get
next
this?
class next week. Hello.
Ma'am, where can I get this link, ma'am?
You people are not getting this because last 4 week classes all already uploaded, right? I have uploaded. I hope you people are getting it.
No, ma'am. Not able to get it. Where can I get it, ma'am?
1 minute, I can share the link. 1 minute, okay.